So Zaira and Zohair, so this question. What happens to the thermal stability of group 2 nitrates changes with increasing proton number, right? So magnesium nitrate is not very stable, while barium nitrate, that's right at the bottom, that's very, very stable, right? So what's the reason?
The
So
size
what
of the
happens?
cation?
Yeah, you get bigger cations, right? So down the group, cationic radius increases, right? So what happens? Charge density and polarizing power decreases, right? Okay, just a second. Okay, so your charge density and polarizing power. Hold on a second. Decreases, so the nitrate ion becomes more stable, right? One second, let me add it, Sheetal. Okay, so your nitrate ion becomes more stable. Okay. So copper 2 nitrate decomposes in a similar manner to group 2 nitrates, right? In equation. So that's pretty straightforward. It's copper oxide plus NO2 plus half O2. Okay. I said this one is about, I guess it's about your transition metals, right? So what complex is formed when you have water? So क्या होगा? That's going to be. So that's going to be copper with water. 1 second. So this one is going to be copper with water, and there would be 6 of them. It's going to be an octahedral complex, and it's going to have a +2 charge, right? When you add NH3 to it, why is the precipitate forming? Because the NH3, if you add a small amount of it, it first acts as a base, and it ends up forming OH ions, right? And those OH ions, they go and combine with, or they form a precipitate. But when you add more NH3 to it, then what happens is that the ligands are substituted, and NH3 takes its place. If you add too much Cl to it, then a tetrahedral complex is formed, and it's 2 minus, right? So it's a standard TK for copper and cobalt. You're going to get pretty much the same reaction. This is going to be blue in color. This one is going to be a pale blue precipitate. For solution C is going to be a deep blue solution. And this is going to be your green yellow. So that's going to be your green yellow solution. And I guess the rest of the question is all about that. Okay. So we don't have to solve this. So next one, what's a polydentate ligand? Like ETA, it's a species that has many lone pairs. And can form multiple or many coordinate bonds with a metal cation to form a complex. Okay, so that's and this is what an ETA molecule looks like. It's got lots of lone pairs. Each one of them is capable of forming dative bonds with the same metal cation. What is meant by the term coordination number? It's the number of coordinate bonds that are formed in a metal complex, right? So it's just the number of coordinate bonds that will be formed in a metal complex. The next one is okay, we've got this is about the stability constant. So we've got the K stab. And what is the K stab? K stab is the is the equilibrium constant for a ligand exchange reaction in an aqueous solution. So an aqueous solution containing this is added to a solution containing equal concentrations of Cr3 plus and Fe3 plus and Pb2 plus. Based on these values, which one is the most stable complex?
Sir, 1.3 multiplied by 10 to the power 25 one.
This one is the number one thing that's going to be formed, right? Second number pair, it's this one, and this is the third most, and this is the fourth one. So if it were up to them, they're going to try and form this thing. So state the type of reaction when this thing reacts with ligand exchange would happen. So ligand exchange would happen, and your iron and chromium, which have water in them, their water molecules are going to get replaced by ETA. Now reduce the relative concentrations of these two things. The first one, I mean, we've already stated that iron is the one that's going to have the highest concentration, and who's going to have the lowest concentration, Pb or Cr? It's going to be Pb, right? Okay, is this clear?
Yes, sir.
And it's just a 1 mark question. The only reason you have to come up with is that it's got a higher K star value. So that means that indicates that it's more stable. And vice versa, the other one has the lowest K star value. This one looks like a moles question. He says the number of moles of water of crystallization in a hydrated ionic salt can be determined by titrating using ETA ions with a suitable indicator. So I think he's talking about the water of crystallization. He's trying to find that out. Now, there's 0.255 grams. You don't know what N is. Okay? That's what the unknown is. So he makes a solution. So the first thing he does is he makes a solution. And there's 0.255 grams of this thing added. And it's a 100 cm cube solution. And what is added? That's Cr2. So make sure you have your calculator with you. Then he takes only 25 cm cube of this sample, right? So he takes a tiny amount of this solution. So only 25 cm cube. And he titrates it, so you're getting ETA, right? And the amount of ETA that's being added is, can you tell me the moles of this? Concentration times volume. What are the moles that we're getting? Anyone, Zohair, Zainab, Maheen? Akshita, what are the moles?
2.096 times 10 to the power negative 4.
Okay, so you're getting this, right? Now the trouble is, what's in the solution? I think what's in the solution is chromium with water, because I think it's going to be chromium aqueous, right? Because the salt is going to dissolve. I mean, the salt over here, it's, I mean, the chromium sulfate that you have over here, it's going to dissolve and you're going to have chromium aqueous, right? Now, what I need to figure out is what's the ratio of eta to chromium aqueous, right? That's the ratio I need to figure this out. So I need to go back and did they tell me? Yeah, it's 1:1, I think. यहाँ पे, if you look over here, the complex, the reaction they're going to have, one chromium is going to react with exactly 1 eta, right? So I know the ratio. So which means I'm going to have exactly the same number of moles, which is 2.096 times 10 power negative 4, right? Is this clear?
Yes, sir.
And based on that, the first thing is I have to multiply these by moles by 4, because this is in 25 cm cube. I need to figure out the chromium aqueous that's formed in 100 cm cube, right? Let's go multiply this by 4. What do you get if you multiply this by 4?
Sir, it's 8.384 multiplied by 10 to the power minus 4.
So 384 times 10 power negative.
Minus 4.
Okay. So anyway, so we've figured out chromium aqueous, right? Now all that chromium aqueous was coming from this hydrated salt. So what are the moles of that hydrated salt? It's going to be half. You clear? This is going to be half, because one salt crystal is going to produce 2 chromium, right? You get the salt crystal has 2 chromiums. Is that clear?
Sir, but how do we know that? Like if it's 2 or 4 or whatever?
Well, they couldn't get you had Cr2SO4 3, right? Dot NH2O. So how much chromium is going
chromium to H2O is 2:1. That's why you divide it by 2.
Yeah, divide by 2, because you found the moles of chromium.
Okay,
So
I
the
got
crystal
that.
is going to be half of that, right? So what is
Yeah.
half of that? कितने moles आ गए? This is 8.384 divided by 2, right?
Sir, it's 4.192 multiplied by 10 to the power minus 4.
Minus 4, right? So now the last thing is we have the moles and we have the mass. So I just need to figure out what n is, right? I mean, there are many ways of doing that. I can figure out the MR. How do we find the MR? That's mass divided by moles, right?
Do
So
you use
it's
the Avogadro symbol formula now? Because you have to
please.
find
What do I need to find?
because what does N stand for? N stands for moles, no? Just number.
No, n is a number, like Al2
Yeah.
SO4, let's say X over here.
Got it.
If I know the MR of this thing, I would know what n is, right? Is that clear?
Yeah, because then you could just add it up and find N.
So you can just do that. So I have the mass and I have the moles. They gave me the mass early on, right? So what do we get? I mean, this is mass over MR, right? Sorry, not mass over MR, mass over moles. MR is mass over moles. So what's the MR now?
Sir, is 608.30.
Kita, what is it?
608.30.
Let's go with 608. So now I need to figure out what. I need a pure table. Does it even know what CR is?
Can you just do 608 divided by 18?
The 608 is the whole thing.
Oh,
The
okay.
first thing
I
is
thought
I need to
it's small.
subtract. I need to subtract this thing, right?
Okay, then you'll get that. Okay.
So I need to subtract this. SO4 thrice is this is 96 times 3. CR doesn't even know what CR is.
52.
So it's 52 times 2, right? So if I subtract 608 minus this thing, I'll get water, right? So what is the amount of water that we have?
Sir, is 210.
So that's 210. Now I need to divide by 18.
Is 11.66. So 11.7.
Yeah, that's going to be roughly. It has to be a
12.
whole number, so it's probably going to be 12. Actually, this one I need to double check this one if we did this. At least we did the math one, right or not? Because
It's
this is 23.
216, not 210.
It's 260. See, this is just 23. This one second. Let me.
I know, 216, like 1/6.
So what do you get then? 2016 divided by 18. What do we get?
12.
12.
Like complete 12.
Exactly 12, right? That looks
Yeah.
better. It's just a sec. But let me just see if I can find the. So which question is this? This is yeah, 12. 12 is the answer. Okay.
But I have a question.
Yeah.
You got the moles 8.384 for CR2, right?
Yeah.
So then how come
Nee,
you yeah.
first we got these moles, right?
Yeah.
But these were in 25 cm cube, right? So
Then you
in 100
multiplied it
cm,
by 4.
you multiply it by 4.
Then you got 8.384. This is for the CR2 that is aqueous.
Yeah. So
But
the
can't
salt,
you say that this is the whole moles though? Why are you halving it? Because half would just be H2O then, right? No, half won't be H2O, but why did you half it?
nee, because this is the amount of CR, right? Like if I have 10 CRs, right? So how many crystals are going to produce 10 CRs? It's going to be 5, right? Because one crystal has 2 CRs, right?
Could you repeat again? My internet disconnected. Like,
Yeah, I'm just saying if I have let's do it this way. If I have one crystal, right?
yeah,
How much CR is going to be produced in the solution? It's going to be 2, right?
yeah.
If I have 10 crystals, right? So how many CR ions will be produced in the solution? That's going to be
Oh,
20,
I
right?
get it. I get it. Okay. Yeah.
So I had the
Make,
moles of this. So the crystal would be half, right?
yeah.
So
Got it.
12 was right. Now the next thing is why do complexes have different colors? Okay, so what happens is that due to different ligands or different complexes, the D subshell is going to split differently. So due to lone pair repulsion from ligands, the d subshell splits creating different energy gaps and if you have different energy gaps, right? So since E is equal to HF, or E is proportional to frequency, or delta E is proportional to frequency, a different frequency is absorbed from the visible spectrum. Okay, is this clear? So basically, it's different delta E due to different because of the difference in how the D substrate splits, and since energy is proportional to frequency, a different frequency is absorbed from the visible spectrum. Okay, remember this is like a standard question which is going to come in every paper. So the next one. So again, it's transition metals. Some transition elements complex state. Two types of the two are optical and geometric, right? Optical is when you have either three bidentate ligands, right? Or you have two bidentate ligands and two monodentate ligands. And geometry, they're probably going to ask they're probably going to ask a question on this. So the first one is the cisplatin and transplatin. TK, you have to remember about this. So he says the complexes have the same geometry shape around the metal line. And he says that, so he says they have the same geometry. You need to know what the geometry is around this thing. It's a square planar molecule, right? So square planar means that it's got 90 degrees completely flat molecule with two Cls and two NH3s. Now, this is just one version. The other version is, this is the cis version. Actually, the other version is that your Cls are on opposite sides. Okay, is this clear?
Yes, sir.
Actually, now, so state the geometry around the metal line. Actually, we already know that. That's square planar. Actually, next thing is the complex CrEn3 exists as two stereoisomers. Actually, this is the ये वाला जो है ना, this one. So now he says that it exists as two stereoisomers, whereas the complex exists as four stereoisomers. And remember, he's only talking about
Sir,
stereoisomers
can you
over
go
here.
up? I didn't see the above answer. Yeah, okay.
It's a square planar. I mean, you should by default already know that this is square planar. Okay, this one you have to remember: cisplatin and transplatin. This is the cis version. The other one is going to be your trans version. So this one is the bidentate ligand where you have optical isomerism, right? So, and this is the bidentate ligand that you have. So I'm going to draw the first one. And he says that there are four different stereoisomers. So that's one. So this is the other one. And the third one is going to be this one. Now this molecule over here is going to have a mirrored version. The mirrored version is going to look like this. Actually, this is wrong. That's not mirrored. The mirrored has to be on the other side. And then you have so then you have to mirror everything very, very correctly. So okay, so that's it. So can anyone tell me what are the other two stereoisomers?
Sir, is this true?
Stereo means the only bidentate mein, the only thing that's possible is optical isomers. There's actually going to be two other optical isomers. The other two optical isomers are going to be, if you look very carefully, the oxygens are like right next to each other. So you could have attached the bidentate ligand in such a way that the oxygens are never together. And for example, if what I can do is, I've got this bidentate ligand, and I can try and keep the oxygens away from each other. You can is this thing clear?
Yes, sir, but can you go a bit above, like the first part? शुरू में जो सबसे पहला क्वेश्चन था जहाँ पे आपने ज्योमेट्रिक और वो लिखा था ऑप्टिकल। I have a question there. इससे भी ऊपर सर आपने कहा इसमें हमें कैसे पता चलता है एक ऑप्टिकल होगा और एक ज्योमेट्रिक, लाइक हाउ डू वी नो? आप अभी बताए थे ना लॉन पेयर्स को देखना पड़ेगा लाइगेंड्स को।
नहीं वो ligands, I'll explain everything. ठीक है. Remember, geometric only happens it only happens in two scenarios. One is whether it's square planar. The other is in octahedral complexes. In octahedral complexes, you have geometric. Geometric is either the ligands are attached together or they're attached opposite to each other. You clear?
Yes, sir.
And in octahedral, what happens is, like, if you have octahedral, okay, what can happen is that, like, if I have an octahedral complex, so let's say it has 4 water molecules, so and 2 NH3s. So the NH3s could be right opposite to each other, and the water molecules could be on the other axis, right? Or it could be that the NH3s are like next to each other, and the water molecules are all together. They clear this is also geometric isomers, that they could be together, they could be opposite to each other.
Yeah.
Is
Okay,
this clear?
sir. Yes, sir.
So optical only happens when this is the only situation when optical will happen. Optical only happens when you have 3 bidentate ligands. Or it could be the other way around, is that it could be 2 bidentate ligands. Or the third side that has 2 monodentate ligands. that will still produce an optical isomer. Optical isomer, you have mirrored versions. So this is your mirrored version.
Optical
Mahin, is this
isomers,
clear?
yeah. जी sir, समझ आ गया. Thank you.
And he was asking for 4, right? So the only thing I did was in the first one, what had happened was that the oxygens were together right next to each other when I attached them. So the second one, the second pair that I've drawn, this one, you can see that none of the oxygens are like next to each other. Okay, so there are 2 mirrored versions, but the oxygens are no longer together. Okay, is this clear?
Okay sir, yeah, yes sir.
That's the next one. So the complex this is formed by reacting CO2 with the conjugate base of so I think he's given you a reaction, and I think you have to use this reaction to figure out basically you have to figure out the intermediate, and you have to now what you have to do is this reaction is not in your course. You have to figure out what's going on your own. So what I think is going on is that this carbon is positive. Let's say spin on the carbon-carbon bond is not breaking. So this carbon is positive. So electrons are attracted to this positive carbon. And the cyclic structure breaks. So these electrons over here, they are repelled. So you've got H, you've got another H, and now you've got NH3. But the N is positive. Okay, full on +1 charge. Why? Because it lost the lone pair to carbon. So okay, what happened to carbon? It had one H, it had another H, and now it's got an oxygen, which is -1. Okay, is this clear?
Yes sir.
And the only thing that will happen in the next step is what was it reacting with? It was reacting with, but there's just going to be this extra H that's going to go and attach to the oxygen -1 on the other side. Okay.
How?
So anyways,
Like, is the then shouldn't the oxygen be on the bottom side so like it attracts that H?
yeah, but it doesn't matter. You don't have to show the next step. You just have to draw the intermediate. So you include all relevant curly arrows. This is the mechanism for step 1. Only step 1. That's it. That's it. Not step 2. Yeah, is this clear?
Yeah.
Okay, then you have this thing. So just the formation of the byproduct E can be minimized, right? So what's happening now is, as you remember, this question always comes. See, ammonia and amines, they kind of react in the same way. So once the first reaction happens, this thing over here is an amine, right? So this amine could further take part in the reaction because it still has an NH2 and it has 2 carbons, CH2 and CH2. और फिर वहां पे ना there's an OH. So what can possibly happen is that once the product forms, the carbon chain could further lengthen, right? Why is it lengthening? Because the product itself can act as a reactant, right? So ammonia reactions will always keep this in mind that these amines which are produced, they can also kind of act as ammonia as well. So they can go back and they can start a chain reaction where the length of the carbon chain could possibly increase. Is this clear?
Yes, sir.
So how do you stop this from happening?
Could
Or
use
how do you
abscissing.
Sir, we just
yeah,
chill it.
don't add too much of this. If you add
Okay.
if you add too much of this, then the product that is formed, this thing will go and start reacting with the product as well. So after the reaction, this should be finished. I mean, there shouldn't be anything. I mean, once the first reaction happens, you should be out of this thing, oxidane, right? So don't add excess oxidane. Okay, so limit the amount of oxidane. Clear? And the next part is compound F can be formed from the reaction of byproduct E with concentrated sulfuric acid. Byproduct E, what's byproduct E? Byproduct E with concentrated sulfuric acid. What does concentrated sulfuric acid do to it? Does anyone know what would it do?
Could you repeat the question?
The question says that the byproduct E reacts with concentrated sulfuric acid. And
So,
we need to figure out, remember, it turns it into an alkene.
and what do we need to figure out?
I think that was it.
Oh, structure. No.
It's forming C4H11.
Yeah.
Need 1 second. Yeah, this thing. So it's probably turning into an alkene, right? The 2 carbons at the ends, they're turning into an alkene. You got an NH at the bottom, in the middle, and you got carbons over here. So there's going to be 2 H's. This one is going to have 2 H's, 1 H, 1 H, right? So you have another, that's C4. How many H's? That's 2, 2, 4, 5, 6, 7, right? And N. I don't know if we're getting that or not. Need compound F. I need to find out what compound F is. I have no idea. ठीक है, compound F का तो नहीं पता.
That is what you just made, no?
Sir, but the formula is given, right? So we just have to make like the structure of the compound up.
नहीं, there's one problem. It's
And what's
C4H7.
that?
नहीं, formula ना कि this is supposed to be F, right? So the formula
But
does
sir,
not match.
in F, like if we also have O, right? But in the up one we don't have O.
No,
मेरे
it's
ख्याल से
just
what's
the arrangement. It's not that they're saying this is just the random arrangement, like C is this much, this. It's not that it's nitrate or anything. It's just like
नहीं,
that.
that's true, but there's still an oxygen left. So I think it's not getting completely dehydrated. One of the OH is going, the other one is not.
Yeah, I think the same.
ठीक है, so it's so let me just try and see what the formula of this other thing is. So you're going to have a double bond. One of the OH goes, NH, and the other one still has the OH. So you
But
got two H's.
it said it's saturated. That means like no double bonds.
Saturated basis. So that means no double bonds. So now what's happening? If it's saturated, I said now, Han, ab batao, okay, it's saturated. So that means that the whole premise was wrong. No alkenes. So tell me what, it's definitely not dehydrating. So what is it doing? Anyone, any idea? What does it do? What does concentrated sulfuric acid do? Apart from dehydration. Yeah. Anyone? Any idea?
Sir, can you explain?
Hmm?
Sir, can you explain this?
And he's saying it's a basic organic compound. So that means the amine is still there. I said what we can only do is, well, it can't form an amide because for amides you need a carboxylic acid and you need an amine, right? So you've got this. The only thing we've got is this molecule, and we need to somehow dehydrate it. That's pretty much it. That means suggest a structure of a type of reaction undergone by. You can't turn it into an alkene. That's out of the question. So I guess the only thing, because sulfuric acid is only dehydration. That's pretty much it. I've got N over here, and I said there's OH, right? And you've got, and then there's the other OH. So let's just check if dehydration happens, and these two are removed, and the N ends up making a third bond with. Like, and the problem is that is this what is the structure now? It's two H's, and you've got two H's. So what formula do we have? That's 1, 2, 3. 1, 2, C4. That's C4. And H is 1, 2, 3, 4, 5, 6, 7, 8, 9. And I've got N and I've got O as well. Do we get the same thing? Are we're kind of getting the same thing. Is this thing clear?
Can you check the MS just to confirm?
I want to check the MS just a second. Okay, so I mean the first thing, concentrated sulfuric acid.
Could it also be that never mind.
Yeah, now I'm going to try in just 1 second. Let me try and see the MS as well for this. Well, we got the right formula at least. I said now concentrated sulfuric acid is only dehydration. Just a second. I said they've kind of given us they've given a different structure. Just a second. Let me go back. As I said, I had OH here and I had an H over here. Yeah, I think ours will be correct as well. It's probably going to be accepted correct. What they did instead was that they removed the OH from here and the H from this one. And they connected the two together. I mean, this carbon ended up joining with this oxygen over here. They ended up making a cyclic structure. I don't know how. Did they give us any hint? It's a basic organic compound. Ours was basic as well. Yeah, ours is definitely going to be accepted because it's just random guesswork. You just had to come up with something that was basic and that was saturated. It's probably going to be accepted. TK, is this clear? I mean, so this was an absurd question. I mean, they just wanted you to dehydrate it. That's it. Is this clear?
Yes, sir.
Okay, but they went for this one. The other one, well, amine as lone, but the other one is definitely going to be acceptable. Okay. As a type of reaction, that's just dehydration. So we wasted a lot of time on this question. So Amna, Akshita, everyone, is this clear? This one?
Yes.
Okay, we've got a rate of, I think it's a rate of reaction. What is meant by the order of reaction? So it's the exponent of the concentration of a reactant in a rate equation, right? Remember this definition: exponent of the concentration of a reactant in a rate equation. You're being asked to figure out what the order is, and they've actually given you everything. So they've told you that IO3 minus 1 is order 1, H plus 1 is order 2, and I minus 1 is also order 2, right? And the overall order is going to come out to be 5. And use your answer to sketch to show the relationship between the initial rates and the concentration of IO3 minus 1 and I minus 1. So rate IO3 minus 1 is order 1, right? So that means directly proportional. That's just going to be a straight line. I minus 1, that's what I minus 1. I minus 1 is order 2, right? Now, since it's order 2, that's going to be a exponential line, right? It's going to go up as because if you increase concentration of I minus 1, the rate of reaction will increase by a much larger amount. ठीक है, is this clear? Or उससे आगे, the other thing is you have to figure the units.
When the order of reaction is 0, will they even write the
order of that they can ask you about that.
No, but like in the
The order.
formula, like how will you know if it's 0?
I mean, if it's not written, it's 0 then.
It's 0, right? Okay.
Because obviously there's no point writing it. So if it's not written, it's definitely going to be 0. Or उसका graph क्या होगा? That's going to be a straight line, right? Nothing happens to the rate, no matter what the concentration is. So you have to find the value of k. That's easy. You just plug in the values. Because there's only one experiment with data, so you just plug that in to tell me what the value is. It's 4.20 times 10 power minus 2. And you have to tell what the unit is. So it's k. Everything gets divided. So it's IO3 minus 1, that's 0.04. And it's H plus 1, so it's 0.015. And the H plus 1 is going to be squared. And then it's 0.025. So that's what a K is, right? So you to tell me the answer and tell me the unit as well. That's remember you always take the units that are written over here. So it's X, it's in minutes, right? Make sure you keep that in mind. So this is rate K times concentration to the power 5, right? So K would be X minus 4 and minute minus 1, right? So it's mole minus 4 and dm3, that's going to be 12. And minute minus 1. So that's what my unit is going to be. Okay, what's the value of K?
It's 7.47 times 10 power 6.
Okay, so hopefully that's probably going to be the correct value. So going back, we found K. Now, since we have K, we can figure out the H plus 1 concentration in the previous experiment. So I'm just going to skip that. You just have to, because you now have the value of K. You've got the initial rate, you've got I minus 1, you've got IO3 minus 1. So obviously you can calculate H plus 1. ठीक है, clear? Just use your calculator. ठीक है. The next part is that the reaction is repeated in two separate experiments. So the experiments are carried out at the same temperature with the same concentration of I minus 1 and IO3 minus 1. One experiment takes place at pH 1. So what's the concentration of H plus 1 at these two pHs? So यहाँ पे it's 10 power minus 1 mole per dm cube. And over here it's going to be 10 power minus 2 mole per dm cube.
And sir, that we know because of pH, right?
It's yeah, take the inverse log and you get this, right? pH is minus log of H plus 1, so that's the inverse log. Clear? So now he's asking for the rate at these two pHs, right? Now the rate equation that you have is this. So I guess if I divide the two rates, because everything else remains the same, the K is the same, IO3 minus 1 is the same, I minus 1 is the same, everything else is the same. So when you're trying to calculate rate, everything else will get cancelled out except for H plus 1 squared. So at the end of the day, when I divide the two rates at different pHs, the only thing that's still left is going to be H plus 1 squared. Well, is this thing clear?
Could you repeat?
This is how you calculate rate, right? They gave us this thing, right? So he's asking you to calculate rate at two different pHs, right? So you're going to use the same formula for rate, right?
Yeah, I understand now. It's just the same concentration. The only thing that changes is H plus concentration.
The only thing that's everything remains constant. So it's basically just H plus 1 squared of the first experiment and H plus 1 squared of the second experiment, right? So at pH 1, that's 10 power minus 1, and that's squared. At pH 2, it's going to be 10 power minus 2, and that's going to be squared as well. So the first one would be 10 power minus 2, and the second one would be 10 power minus 4. Or it's 10 power 4 divided by 10 power 2, which I think is 10 power 4 minus 2, which should be 10 power 2, and that's going to give you 100. Okay, is this clear? Or you can use your calculator. I'm not sure if
Yes, sir, it's
probably
100.
I say this one you have to remember this one that this specific example of iron 3 ions acting as homogeneous catalyst, right? So step 1, step 2, step 3, and you have to figure out what the so this one you just have to remember this reaction. Hey, not this one, just a second. Then it's no, sorry, not this one. This is just a random reaction. That reaction, homogeneous catalyst one, that was with S2O8 and SO4 ions. This is not that reaction. So basically, you just have to, in this case, you just have to figure out the 3 steps yourself. And he's told you that it's second order with respect to I minus 1 and first order with respect to Fe3 plus. So yeah, then you just have to do this. I mean, you just have to be creative and figure this one out. So I guess if I try and do this, it's I mean, there are many ways of doing this. But I have to make sure that there are 3 steps involved. So let's start with Fe3 plus and I minus 1. So what do they do? Maybe they So they can. If I do it in the first step, the reaction is over already. So I have to think about something else. Maybe they combine together. So they form, and then this FeI 2 plus. Maybe it combines with this in so I minus 1. So what's going to happen now if it combines with I minus 1? So let's say I join these two again. It's going to be 1 plus. And let's say in the last step, plus 1, you are minus 1, plus 2, you're plus 1. And in the last step, these two end up. I mean, there's one Fe3 plus that's left. And then eventually they all get converted into Fe2 plus and I2. It's going to be 2 Fe2 plus because they're 2 Fes. So I just created these random steps. You clearly, and it's up to you. You've got total freedom to create any random step that you like. I said now in this case, ये बताओ कि which one is going to be the slow step, because with respect to I minus 1, it's order 2, and with respect to Fe3 plus, it's order 1. So which one is the slow step?
The second step.
Because if I take the second step as the slow step, then my rate would depend on these two things. But my Fe2 plus is an intermediate. That indirectly depends on these two things. So that means my rate indirectly depends on Fe3 plus and I minus 1 again. Now I minus 1 shows up twice, so that's order 2. And Fe3 plus is once. So this is going to be the slow step. So the second step is going to be my rate determining slow step. ठीक है, is this clear?
Yes, sir.
अच्छा चलो ठीक है, let's we'll continue with the same paper. ठीक है, remember this is we will ठीक है, I've shared the plan. But it's not opening. ठीक है, it's a big file, needs shutdown. So we're going to do the same paper tomorrow as well. Then next time after that we'll do the other paper. ठीक है, तो चले ठीक है everyone. Take care. Bye.